All right. Hello. Check one, check two. We have sound removing here. Hello. Welcome. My name is Alexander Booth. I am the head program instructor and head facilitator for the IBM Data Science Professional Certificate / 10-week mini bootcamp. This is your week 9 review, week 10 preview. Yeah, crazy. Kind of hard to believe that our 10th week, our last new content week of the boot camp or the certificate is coming up already this week. So we'll review kind of where we are, where we came from in week 9, what we covered, what we are expecting for the capstone, and then we'll dive into the just the remaining topics needed for week 10. So let's go ahead and do that. Yeah, so as you all probably know by now, week 9 and week 10 is the data science capstone project. This is where we take on the role of a data scientist at a competitor, maybe Space Y, to, of course, the popular SpaceX organization. Our goal is to analyze public and open source data from SpaceX about its launches over the past 20 years or so and try and analyze to see if we can predict the probability that a booster rocket will be reused given the type of launch, such as location, payload, orbit destination, etc. This will help us also be able to come up with an expectation for cost. If we are more likely to be able to reuse our booster rockets, of course, the overall cost of the launch will be less. But yeah, let's dive into it. Obviously, week 9 was last week, so we kind of go through this again. We have a lot of expectations for the capstone here. But yeah, we had our live session on Monday, so thanks everybody for joining. As I mentioned during that session, we introduced the capstone scenario where we're analyzing SpaceX launch data to build a model that predicts whether a Falcon 9 first stage booster rocket will land successfully. We focus on the first half of the capstone workflow, understanding the business problem, setting up and organizing your GitHub repository, reviewing the final project submission expectations, and then walking through the data collection notebooks, including API and web scraping, as well as the data wrangling and exploratory data analysis notebooks as well. So before we get too far down the roads here, let's quickly recap the reminders from week 9. The final submission for the project will be a PDF. I'm expecting to see your slide deck in PDF format. You'll do a file upload through the IBM online campus. And at the end of your slide deck, you should include a link to your public portfolio, to your GitHub that contains the executed notebooks and code from weeks 9 and 10, as well as some sort of README and or short executive summary / written report. We can also include any supplemental materials such as the data files or saved images from your outputs. Let's see. I do have the slide deck around here somewhere. Let me go ahead and actually pull that up. One quick reminder that I wanted to give on the slide is that I don't want it to just be a collection of screenshots. If you look at the skeleton slide deck that we gave you, you'll see it's just a lot of bullet points with a lot of placeholders for visualizations, right? Your maps, your dashboards, your machine learning models, right? The results of it, your exploratory data analysis, etc. But that's really not why we do slide decks. That's not really why we do data science or data analytics. I want you to add your own interpretation, conclusion, and business insights. How are you driving actionable decision making with your findings? The goal is to show that you can take the outputs from the code, from the analytics, from the notebooks that we create, and actually turn them into a compelling data-driven story. Let's see. For the GitHub, I do have an example. Let's see if I can go find some of our repositories on that. I think we created one the other day. So yeah, for the GitHub, we walked through how to create this, create a new repository, and then include a README, which you can edit in place by clicking on this pencil icon. And then when you have your code ready to go, you can simply upload files and then drag and drop from your folder. So let me just show what that would look like here. You'll see that. Let's say that I want to do 9.5. We can just drag that up here as well. And you'll see this will upload the folder structure as well as the completed files and everything. So again, do all the code in your IBM cloud environment. Once you've finished executing your code, download the files to your computer. From there, organize them into the correct folder structure, however you want to organize it, and then drag and drop those files and folders into the GitHub UI through the interface. And we should be good to go. Let's see. I added some links for GitHub about how to create a repository, how to upload files. If you scroll up in the chat, you'll see there's a lot of good resources that we've talked about with this. I think, yeah, Karen has a whole kind of page here about how to organize your project into folders that you'll see for classic data science projects and capstones in the real world. Again, just reach out to myself or Karen if you have any issues with GitHub. All right, so let's see. With the actual code and notebooks themselves, we ran through the first few notebooks in 9.4 and 9.5. Where are we? So let's just, yeah, go check. We'll see in module 9 here, yeah, we had Um, one, two, three notebooks in 9.4, and then I think two notebooks in 9.5. So we ran through all five of those notebooks in the live session, which you can see here. One quick thing just to highlight, we'll start with some of the data collection notebooks. The very first notebook that you run into in Module 9 is the SpaceX API. The SpaceX API library that we were using in the class is currently offline. So because of that, when you try to request information, you'll probably end up with a 521 or a 522 error code. And yeah, you'll see that this means the web server is down. The API is no longer being hosted. So no worries. Just know that your notebook for the data collection API will not succeed. If you scroll through mine, you'll see that I tried my best, but it had a whole bunch of errors. So don't worry about it. The other notebooks in Module 9 and Module 10 all stand alone, so you should be able to complete the other four notebooks in Module 9 without issue. Moving into the rest of the notebooks, we worked through data web scraping, right? So being able to scrape data from Wikipedia. Again, nothing too bad here. Mostly just filling in the gaps and building out our pandas table. Then we worked through our data wrangling, where we cleaned the data pulled from the API as well as from the web scrape. And you'll see that we have all those data sets backed up for you. So that's why you don't need the API in any of these downstream notebooks. So yeah, we will understand our data, make sure we understand kind of the domain expertise that we're looking for here, especially around kind of complex things like the different orbit types. We'll do all of our feature engineering, create new columns, make sure that we're ready to go for our modeling. And then we will end 9.4 with our exploratory data analysis. There's also our SQL review lab. Essentially, we're going to write our launch data into a SQLite database, and then it's up to you to practice and show off your SQL skills by writing simple queries against the database here. And you get to write like 10 queries or so. I had a lot of fun with this notebook. You know, I love me some good SQL problems. Then we moved, oh, this was part of 9.5 actually. Then we rounded out the whole first half of the capstone here with our EDA data viz project, which is where we really did our exploratory analysis and preparation for modeling. So creating our scatter plots or our cat plots with Seaborn, looking for outliers, looking for correlations, looking for patterns and signal that could possibly predict the probability of a launch. Again, one thing that's pretty clear is that launch rates have gone up over time, and it kind of makes sense that more recent launches are more likely to succeed. So then we did our one-hot encoding, and I think fully prepared the data for machine learning. So yeah, pretty good week. Again, taking the data, getting the extract, transform, and load, writing some SQL queries, looking at correlations, doing some exploratory data analysis. That's the first half of our data science workflow. And that's going to take us into module 10 here. Let's see, big idea for the week for week 9. Don't just treat the tech capstone as running notebooks and submitting screenshots. Treat it like a real business oriented project. Organize a repository. Clearly explain the business problems for non-technical stakeholders. Document everything. Summarize your findings. Connect your analysis back to actionable insights like booster reusability and cost optimizations, and really try and make a stance and think critically of your responses. Sweet. I think that takes us into week 10 here. So week 10 was officially on. Looks like we're recording, I think. That was odd. Zoom just totally crashed on me. I don't know if this is the same recording or if this is a different recording. I think this is actually going to be split into two recordings. So sorry about that. I see that there's a recording being processed right now. So we'll just call that, I guess, the week 9 review. And I guess we'll call this one the week 10 preview. Yeah, so sorry, it looks like Zoom crashed in the middle of my last recording. So I guess you're getting another part two. So again, hello, welcome. My name is Alexander Booth. I'm the head program instructor and head facilitator for the IBM Data Science Professional Certificate and 10-week bootcamp. This is your Module 9 review and Module 10 preview. We just finished our Module 9 review, so I guess catch that in the last video if you haven't. And this is our Module 10 preview. The goal here is just to recap the expectations for week 10, how you're going to be closing out the boot camp here, and what you'll expect to do with your visualization, slide deck, and final report. So yeah, we'll come back to Karen's note here because it is a really good one. So yeah, welcome to week 10. Week 10 is the final week of the IBM Data Science Bootcamp, and this is the week where everything comes together. While last week we focused on collecting, cleaning, and exploring the SpaceX launch data, this week we're turning that into insights, predictive models, and data applications and dashboarding for stakeholder communication. We're going to be building interactive analytics. We're going to be building interactive maps with Folium and dashboards with Dash Apps and Plotly. We're going to be adding dynamic filters and connecting inputs to charts and turning analysis into self-serve analytics. Then we're going to work on our machine learning model. We're going to build out our final feature set and do a full machine learning workflow where we try multiple algorithms, tune our hyperparameters with a grid search, and evaluate our models with various metrics. Our goal here is to see if we can predict whether SpaceX will successfully land the first stage of its booster rockets. Then we're going to gather everything up, everything from the data wrangling, data extraction, exploratory data analysis, predictive models, and business intelligence. We're going to grab all of our images, screenshots, and final outputs, put them into a slide deck where we're going to walk through and show the results again of our interactive maps, of our dashboards, and really what we're looking for is explanations and signal and recommendations. Why do we have this graph? What's the point of it, right? How does it drive downstream decision making? How does it describe patterns in the data, right? Same thing with a machine learning model. You're going to walk through your modeling development cycle and your modeling steps, but then you're going to really hound into the metrics. Where are the limitations of your model? Where is it bad, and why do you think it's bad? What is the bias that exists in your model? But how can it also be used? What are the benefits? Where in the data workflow and data ecosystem do you think this model can actually drive insights, right? How trustworthy are the probabilities and how relevant are they? So again, we're looking for your synthesis of the data science, not just a slide deck of a bunch of screen grabs. The bigger picture here, we walk through the full enterprise business data science lifecycle from getting your data from its raw source, analyzing it, building out predictive models, and packaging that all up into a compelling data story with interactive and self-serve analytics. Things to focus on this week. The dashboard can be as complicated as you want it to be. Definitely recommend getting a simple version up and running, so a minimum viable product, and then working on increasing its complexity as needed. Try comparing multiple algorithms or multiple grid searches, multiple hyperparameters. Be curious about the algorithms, the models, and the metrics that it's for that are returning. In my example in GitHub, I added in a random forest and an XGBoost because we've talked about them a lot in this bootcamp, and of course, I want to see how they work when compared to a logistic regression for this use case. So be curious, try adding more models, more metrics, right? Really focus on understanding what, when, why, how, and how to interpret the results of our modeling workflows. Make sure to also start and finish up your report and repo. The earlier that you start, the better. As you'll see, I got the due dates down here. So remember the final deliverables that I'm expecting. You're going to submit a file upload with your slide deck as a PDF to the IBM campus. From there, in one of the slides should contain a link to your public GitHub repository. That repository should hold all of the notebooks from week 9 and week 10, so about 8 notebooks, as well as the slide deck and a README and or short executive summary slash written data report. You can also supplement that with any of the data or images or HTML pages that you generate in the course of this project. The final due dates for this project is sometime between June 24th and 28th. 24th is next Wednesday, which is the official due date, but I typically give you a few extra days, especially that weekend, just to finish knocking everything out. The earlier you turn things in, the better. You may have to ask for an extension through the campus if you submit on the 25th through the 28th, but it should be granted automatically. Let me know if you have any issues with that. Karen and I are going to try and start grading over the weekend, but since you have that time to turn in the project, we'll start grading it between the 29th and 30th or whatever. On our end, we have to have the grades in by the 1st, but I don't think there's too many of y'all, so we should be able to get that done. It could take up to 2 weeks after we submit our grades for everything to go through the audit and appeal process, and I expect all the final grades to be released sometime the week of the 13th. Let's see. Submit your project as early as you can, which gives Karen and I more time to grade them. Some notes, don't overcomplicate everything. Like I said, it can be easy to get bogged down in the machine learning or the dashboarding, but make sure when you start, look for that minimum viable product, that MVP. Working is always better than perfect. Similar thing with the machine learning. Understanding here is more important than memorizing every hyperparameter or every syntax, right? For all your different algorithms. Remember, your report should tell a full story, not just repeat or show outputs from notebooks or notebook cells. Start early. Again, just to reiterate, be conscious of your time here. This week goes fast, and we have to have grades in by the 1st. So otherwise, it won't get graded and you won't pass the boot camp. I've got a link full boot camp submission here. This is from a few months ago. She did great. Her slide deck looked really well done. She had some awesome insights and conclusions as she filled this out. We'll just show a few here. Obviously, you'll see that she's got her link to her GitHub as well as like full trees and images and results of exactly what she's doing. And when we get to some of her visualizations, she should have some of those here. Yeah, with good like interpretation, conclusions, etc. So she did a really good job with this. She also included her README, which described the project, as well as a report, just a short couple pages describing the project, what the point of it was. And this way, as future employers potentially look at your portfolio, they can quickly see and summarize and go, oh, you do know what you're doing, and this was the scope of the project. They're not going to go through your notebooks. They're going to look for some quick report or written summary to understand what exactly you've done as part of your portfolio. Big ideas here. Data science doesn't end with a model. It ends when you can clearly communicate the results and someone actually uses them. So a couple of things to note here. I got a couple small ones. In 10.1.3, you may run into some issues with the OpenStreetMap giving a warning about a lack of refer. If you switch the tile to CartoDB positron, that should hopefully remove that. It's just basically a different map layer without that warning. The Plotly Dash app, try not to get too bogged down by it. You do have your own, I give you freedom there if you can follow the instructions verbatim, but really be curious and try and extend it. You have the freedom to create your own interpretation of the application. Just for completeness on this, you'll see that Karen kind of took the time to go through the Dash app and actually refactor and restructure some of these dots and bubble plots more as bar charts, which tell a little bit more of a compelling story. And you can even customize the colors of these bars and everything too. So that's just one way that you can just customize your Dash app as well. And then finally, for the machine learning project, again, be curious, try and extend it as much as you want to. Again, in my work on my GitHub that I'll show in a minute, I did a random forest classifier and an XGBoost just to see how they compared to some of the linear models that we did. I also show how to use Pickle to save and load a model for inference by containerizing and deploying to API and serving endpoints as needed. Yes, it should be a pretty good week here. Like I mentioned, everything is already backed up in my GitHub. If you have any issues with it, you'll see that I've already got everything run for the week. So you're going to 10.1, you'll see that we have a couple notebooks here around creating our Folium maps, and then one about creating our Dash apps. So you'll see I actually have my solution too, which includes bar charts, as well as the original solution I put together and then the original unsolved about what you need to fill in. And then yeah, the Folium maps, you're not going to see them render inside of GitHub here. Instead, I saved everything out to an HTML file, which you can then like open up in its own thing. I was going to say let's see if I can actually try and open it. There it goes. Very cool. So you can see that I have my little like interactive folium of what I'm supposed to be creating here with all the points for all the launches that have been done right across the country. So pretty cool. Let's see, what else do I have? And then I think that, yeah, then that also takes us to the BI interactivity self-serve analytics half. And then on the machine learning side in 10.2, you'll see that I already ran the machine learning notebook as well. Again, use my code as resources and references, right? I fully expect you to take this your own and do your own work and come up with your own questions and be curious, right? So you'll see you'll test out a whole bunch of different algorithms. We'll get different performances. We got different metrics, and your goal is to compare all of them. And then yeah, I added an XGBoost and I also walk through how to load models. Once you have your model, you can save it off as a binary pickle file and then load that model in to do batch inference. So definitely watch the well, I guess this is the week 10 preview. Definitely go and like watch the week 10 lecture when it comes out next week. It should be pretty good as we run through these notebooks and kind of information. All right, sorry for the short video here, but I know this is part two of the week 9 review, week 10 preview video. So again, yeah, sorry for Zoom crashing for some reason. But yeah, please reach out on the forums if you have any questions as we start wrapping up. Um, Maybe this is one long video. I'm just gonna sound so dumb at the end of this if this is just one long video. But yeah, again, hopefully you all kind of work your way through all of this successfully. And please reach out if you have any questions in the forums. We'll be around Monday next week. We'll do our last week 10 live session at the normal time, or maybe it'll be a structured office hour. I may have a work thing, so I'll try and get the recording up sometime next week for the week 10 live session. And then we'll do our grading and close us out. So no quiz either for module 10. Just get your slide deck ready and clean up your code and get your report in order. All right. Thanks, everybody. Have a great weekend here. Good luck finishing up your capstone, and I'm looking forward to seeing the results and your conclusions. Good luck, everybody. Thanks for watching the video. Have a great night, and I will see you soon. Cue the outro music. Do, 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 do. Do.